Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. SbCl5 is a strong Lewis acid and oxidizing agent. When an allylic vinyl chloride substrate reacts with SbCl5, it can act as a hydride chloride abstractor, oxidant, removing electrons from the substrate. Moving on to the next step. The starting material is a cyclopentadiene chloride, an 8-membered carbocyclic ring containing 2 double bonds and a CCl bond. This is consistent with a structure like chlorocyclotha, 2,5-diene or similar, which upon ionization and rearrangement can give cyclotetraene, COT-derived cation. Moving on to the next step. SbCl5 abstracts the chloride ion from the allylic chloride to form a carbocation. The reaction RCl plus SbCl5R plus SbCl6- with 2 equivalents of SbCl5, 2 chloride abstractions can occur, or 1 chloride abstraction followed by further oxidation. And for the final step, the cyclopentadiene chloride, upon treatment with 2 equivalents of SbCl5, undergoes ionization. The chloride is abstracted by SbCl5 to give SbCl6- and a carbocation. The resulting 8-membered ring carbocation can lose another hydride or undergo further oxidation elimination to generate the cyclotetraene dication, COT2+. COT2+ is a 6-pi-electron aromatic system, Huckel, 4n+2 with n is equal to 1, making it stable. Cyclotetraene dication, COT2+, has 6 pi electrons and is planar aromatic, satisfying Huckel's rule, 4n+2, n is equal to 1. The 2 SbCl5 molecules each abstract 1 Cl or facilitate 2 electron oxidation, giving COT2+ with 2 SbCl6- as counterions. Option A. COT2 dianion would require reduction, not oxidation by SbCl5. SbCl5 is an oxidant, not a reductant. Option C. Simple neutral COT would require only elimination of HCl, not involvement of 2 SbCl5 as oxidizing agents. Option D. A mixture of dianion and dication is chemically unreasonable under these oxidizing conditions. Therefore, the correct answer is B. Therefore, the correct answer is option B.